Hello students, I hope that you are good, well and fine. In today's session, we will be learning about definite integrals. Okay, so what are definite integrals? Okay, so let's see about them. So previously, we have seen indefinite integrals. Okay, and discussed few method of finding them. Clear? Okay, like a method of substitution, if you remember, method of using trigonometric method by parts, okay, integration using by parts, and all other things. Okay, the definite integral has a unique value. Okay, a definite integral is denoted by this integral from a to b. Lower limit is a, upper limit is b, fx dx. Okay, where a is called the lower limit and b is called the upper limit. The definite integral is introduced either as the limit of a sum or if it has an antiderivative f in the interval, closed interval a to b. Then its value is the difference between the values of a at the endpoint, that is fb minus f of a. Okay, clear? Now, fundamental theorem of calculus. So first of all, area function. So this definite integral with the lower limit a, upper limit b, fx dx represent the area of the region bounded by the curve y is equals to fx. The ordinates x is equals to a and x is equals to b, and x-axis. So area enclosed or bounded by the region. What region? Y is equals to fx curve. The ordinate x is equals to a and x is equals to b, and also the axis. Okay. Now, let x be a given point in closed interval ab. Then definite integral from a to x fx dx represent the area of the light shaded region, as you can see or refer figure 7.1. Okay. Here it is assumed that fx is positive for x belongs to the closed interval a to b. The assertion made below is equally true for other functions as well. The area of this shaded region depends upon the value of x. Okay. Now in other words, the area of this shaded region is a function of x. As you can see, we denote this function of x by ax. We call the function ax as the area function, and it is given by area function which depends on x is equals to definite integral from a to x fx dx. As you can refer this diagram, so x-axis and y-axis. Okay, now an x-axis we are taking ordinates from a to b, as you can see, and this curve is y is equals to fx. Now as you can see, the area or the region bounded by these x is equals to a ordinate, b is equals x is equals to b ordinate, x-axis, and the y is equals to fx curve, as you can see. So this is what my area function depending on x. Okay. Clear? Okay. So based on this definition, the two basic fundamental theorems have been given. However, we only state them as their proofs are beyond the scope of this textbook. Okay, so we only be discussing small things. Okay, clear? Basic things. Now fundamental theorem of integral calculus. So what first fundamental theorem of integral calculus says? So theorem 1 says, let f be a continuous function. So first of all, f must be a continuous function. Okay. On what? On closed interval a to b. Okay. So f must be continuous function on closed interval a to b, and ax, which is our area function depending on x. Then this area function depending on x, if you derivate it, a derivate with respect to x, you will get fx for all x belongs to the closed interval a to b. Simple? Okay. I hope it is clear to you. Okay. So now second fundamental theorem of calculus says that if f is your continuous function, if f, small f we are talking about, in the previous or the first fundamental theorem we also talked about small f. So if small f is continuous function defined on closed interval a to b, okay, we are talking about closed interval. In both of the theorems we are talking about in closed interval a to b, okay, and f be an antiderivative of f, then capital F, take capital F as an antiderivative of f, then definite integral a to b fx dx is equals to capital Fx, okay, is equals to capital Fx from a to b, or in other words this represents what thing, that capital F of b minus capital F of b. Okay, I hope it is clear. Okay, now let's see some remarks. So in other words, the theorem 2 tells us that definite integral from a to b fx dx, value of the antiderivative f, capital F of f at the upper limit b minus value of the same antiderivative at the lower limit a. Okay. Okay, now second point, this theorem is very useful because it gives us a method of calculating the definite integral more easily, okay, without calculating the limit of a sum. Okay, now the crucial operation in evaluating a definite integral is that of finding a function whose derivative is equal to the integrand. This strengthens the relationship between differentiation and integration. Okay, okay. Fourth remark says, in definite integral from a to b, the function f needs to be well defined. First of all, this small f must be well defined and continuous in closed interval. We are taking continuous in closed interval, okay, as you have seen so far. So for instance, the consideration of definite integral minus 2 to 3 minus 2 to 3 x product with x square minus 1 power half, which is root. So since, as you can see, the f expressed by x product with x square minus 1 root, okay, is not defined in what portion? In minus 1 to 1. Okay, so clear? Okay, I hope it is clear to you. Okay, so steps simple. Now let's see some steps to calculate definite integral a to b fx dx, how you are going to calculate them. So let's see. So find the indefinite integral. So you have to find first of all indefinite integrals. Let this be capital Fx. Okay, now there is no need to keep integration constant c, because if we consider fx plus c instead of fx, we get definite integral a to b dx is equals to fx plus c a to b, such that f of b plus c minus f of a plus c, this means f of b minus f of a. Okay, you do not have to write what? You do not have to write this extra constant c. Clear? As this can be eliminated. Okay, now second, so then after finding the indefinite integral, you evaluate capital F of b minus f of a, which is the value of definite integral a to b fx dx. Okay, we now consider some example. From them you can see that how we are going to apply our theorems, how we are going to use the fundamental okay, so fundamental theorem of integral calculus first and second. Clear? Okay, so let's see example number 25. So this example says, evaluate this definite integral 2 to 3 x square dx. So first of all, this x square is well defined on this interval and continuous from closed interval 2 to 3. Yes, so this means I is equals to a definite integral from 2 to 3 x square dx, since first of all finding the indefinite integral of fx, which is integration x square dx. Now you all know x cube by 3 will be its answer, so this will be what? My capital Fx. Now capital F of 3 minus F of 2, the second step will be capital F of 3 minus capital F of 2. So this means 27 minus 3 by 8 by 3, this means 19 by 3. Okay, this means 19 by 3. Okay, now second, evaluate definite integral 4 to 9 root x divided by 30 minus 3 by 2 whole power 2 dx. Now the first thing is to find the indefinite integral. Okay, so let's see how you are going to find the indefinite integral. So we will be using what? Substitution method. So we will be using what? Substitution method. So as you can see, what I will be taking is, so 30 minus x power 3 by 2, I'll be replacing it by t. This means dt will be minus 3 by 2 root x dx. Okay, in other words, I can replace root x dx by minus 2 by 3 dt. I can replace it. Okay, now this means this indefinite integral root x by 30 minus x power 3 by 2 whole power 2 dx will be minus of 2 by 3 indefinite integral dt by t square, which is further can be rewritten as 2 by 3 1 by t. Okay, now this can be replaced, t can be replaced in terms of x, which is 30 minus x power 3 by 2. This will be what? Your capital Fx. This will be what? Your capital Fx. So therefore, by second fundamental theorem of calculus, we have what? F of 9 minus f of 4. So f of 9 means 2. So you can take 2 by 3 common, so 1 by 30 minus 27 minus 1 by 30 minus 8. You can have 1 by 3 minus 1 by 22. So this will gives you 19 by 99. Okay, clear. Now third, I is given, evaluate in a definite integral 1 to 2 x dx by x plus 1 x plus 2. So how you are going to first of all, how you are going to evaluate this indefinite integral? So we will be using now partial fractions. So using the corresponding partial form, you will have minus 1 by x plus 1 plus 2 by x plus 2. Okay, now from here what you can get is integration of x dx, the indefinite integration of x dx by x plus 1 x plus 2 is equals to minus of log modulus x plus 1 plus 2 times of log modulus x plus 2. Okay, this means this equals to fx. Now by using second fundamental theorem, what you can get is very simple, that f of 2 minus f of 1. So f of 2 means minus log 3 plus 2 log 4 and minus log 2 plus 2 log 3. This means what? Now minus 3 log 3 plus log 2 plus 2 log 4. Using the log properties, what you can get? You can easily get log of 32 by 27. So this will be your answer for this definite integration. Okay, now fourth example says, if I is definite integral 0 to pi by 4 sine q 2t cos 2t, then how you are going to find it? Quite simple. So first of all, find the indefinite integral. Okay, sine cube 2t cos 2t dt. Okay, now put sine 2t is equals to u. This means du will be 2 times of cos 2t dt. This means cos 2t dt is equals to half of du. This means what? This means integration sine cube 2t cos 2t dt will be half of integration of u cube du. This means u power 4 by 8. This means sine power 4 2t by 8. This means f of t will be what? This sine power 4 2t by 8. Okay, now this means The second fundamental theorem we will be applying, and using that you will get f capital F of pi by 4 minus capital F of 0, which means 1 by 8 sine 4 pi by 2 minus sine 4 0, which means is equals to 1 by 8. Okay, simple. Okay, now we will be jumping on exercise 7.8. okay, so the exercise 7.8 first question, evaluate this. So definite integral minus 1 to 1 x plus 1. So this will be what? Indefinite integral. First of all, evaluating indefinite integral. X plus 1 dx is equals to x square by 2 plus x is equals to fx. Now second fundamental theorem says f capital F of 1 minus capital F of minus 1 will gives you half plus 1 minus half minus 1, which means half plus 1 minus half plus 1. This means half can be cancelled. You will get just 2. So your answer will be 2. Okay. Now definite integral from 2 to 3 1 by x dx. Okay, so this means just nothing but 2 to 3 1 by x dx means the integration, the indefinite integration for 1 by x is just nothing but log mod x. This is your capital F. Okay, this means f of 3 minus f of 2. This means log 3 minus log 2. This means log 3 by 2 will be your answer. Okay, now third, so 1 to 2, definite integral 1 to 2. Now 4x cube minus 5x square plus 6x plus 9. This means what? As you can see, this means I will be what? Your definite integral from 1 to 2, 4x cube minus 5x square plus 6x plus 9. This means what? As you can see, indefinite integral 4x cube minus 5x square plus 6x plus 9 will be x power 4 minus 5x cube by 3 plus 3x square plus 9. As you can see, this will be your capital F. And from here what you can see, you can easily see that capital F of 2 minus f of 1. This means 2 power 4 minus 5 multiplied 2 power 3 by 3 plus 3 multiplied 2 power 2 plus 9 multiplied 2 minus 1 power 4. Clear? I hope it is clear to you. Okay, minus 5 multiply 1 cube by 3 plus 3 multiply 1 square plus 9. Okay, as you can see, just simplify, rearrange the term, you will get 33 minus 35 by 3, 99 minus 35 by 3 and 64 by 3. Okay, I hope it is clear to you. Okay, now fourth problem says definite integral 0 to pi by 4 sine 2x dx will be, first of all find the indefinite integral. Sine 2x dx will be minus cos 2x by 2. This will be your capital Fx. Now using second fundamental theorem, you will get capital F of pi by 4 minus f of 0. This means minus half cos 2 times of pi by 4 minus cos 0. This means cos pi by 2 minus cos 0. Cos pi by 2 is 0. Cos 0 is 1. So 0 minus 1. So you will get 1 by 2 as your answer. Now fifth problem says definite integral 0 to pi by 2 cos 2x. So you will have indefinite integral cos 2x dx will be sine 2x by 2 will be your capital Fx. Now using second fundamental theorem, capital F of pi by 2 minus f of 0, half times of sine 2 pi by 2 minus sine 0. Sine pi minus sine 0 will give you 0 as your final answer. Okay, now definite integral 4 to 5 ex dx will be what? As you can see, okay, so this will be what? Evaluating your indefinite integral ex dx will be ex. This means capital Fx will be ex. Now capital F of 5 minus f of 4, e power 5 minus e power 4. So take e power 4 common, you will get e minus 1. E power 4 multiply e minus 1 as your final answer. For this seventh problem, you can see I will be what? Definite integral from 0 to pi by 4 tan x dx will gives you indefinite integral tan x dx will be minus of log modulus cos x will be your capital Fx. This means f of pi by 4 minus f of 0 means minus log cos pi by 4 plus log 0. This gives you what? 1 by root 2 and 1. You all know cos log 1 is 0. This means this will be what? Half of log 2 value. Okay, simple. Now eighth problem, definite integral from pi by 6 to pi by 4 cosec x dx. You all know indefinite integral for cosec x dx will be what? Log of modulus cosec x minus cot x will be your capital Fx. Now using for second fundamental theorem, capital F of pi by 4 minus capital F of pi by 6, this means log of modulus cosec pi by 4 minus cot pi by 4 minus log cosec pi by 6 minus cot pi by 6. Okay, now log root 2 minus 1 modulus minus log 2 minus root 3 modulus. This means using log property you will have this as your final answer. Okay, now ninth problem. Ninth problem says definite integral from 0 to 1 dx by root 1 minus x square will be what? As you can see, first of all we have to evaluate first we have to evaluate indefinite integral dx by root 1 minus x square, which is, we know that sine inverse x. This means sine inverse x will be our what? Capital Fx. So this means using second fundamental theorem, what you can get is, okay, what you can get is a capital F of 1 minus f of 0. This means sine inverse 1 minus sine inverse 0. This means pi by 2 minus 0. This means pi by 2. Okay, now definite integral 0 to 1 dx 1 plus x square. Okay, so this means what? Let this will be, first of all, indefinite integral will be dx by 1 plus x square. You all know this integration is tan inverse x. This means tan inverse x is equals to capital Fx. This means what? Capital Fx. Using second fundamental theorem, you will get capital F of 1 minus f of 0. This means tan inverse 1 minus tan inverse 0 pi by 4. Okay, now 11th problem. Definite integral 2 to 3 dx by x square minus 1. This means indefinite integral dx by x square minus 1 will be half of log x minus 1 by x plus 1 is equals to capital of Fx. Now using second fundamental theorem, you will get f of 3 minus f of 2. This means half of log 3 minus 1 by 3 plus 1 minus log 2 minus 1 by 2 plus 1. You will get half of log 2 by 4 minus 1 by 3. After using properties of log, you will get half of log 3 by 2 as your final answer for this 11th problem. Now 12th problem, definite integral from 0 to pi by 2 cos square x dx will be, as you can see, first of all, indefinite integral cos square dx can be reduced to 1 plus cos 2x by 2 dx. This means x by 2 plus sine 2x by 4 is equals to half x plus sine 2x by 2. This will be what? Your capital Fx. This means f of pi by 2 minus f of 0 will gives you what? Pi half times pi by 2 plus 0 minus 0 minus 0. This means pi by 4 will be your final answer. Okay, now 13. So closed interval, definite interval integration 2 to 3 x dx by x square plus 1. What will be your answer for this? This will be, first of all, we have to evaluate the indefinite integral x divided by x square plus 1 dx. This gives you what? Half of integration 2x by x square plus 1. By using the substitution method, what can you get? Half of log 1 plus x square is equals to Fx, capital Fx. This means what? Capital Fx is this. This means using second fundamental theorem, f of 3 minus f of 2 will be half of log 1 plus 3 square minus log 1 plus 2 square. This means log 10 minus log 5. Half multiply log 10 by 5. This means half multiply log 2 will be your final answer for this. Okay, now 14th says definite integral 0 to 1 2x plus 3 divided by 5x square plus 1. So quite simple. So indefinite integral 2x plus 3 by 5x square plus 1 dx will be half of 1 by 5th of integration 5 2x plus 3 by 5x square plus 1 dx. This means 1 by 5 10x plus 15 5x square plus 1 dx. Using what? First of all, separate them, you will get this. Now after separating, you apply the substitution method in this. You will get 1 by 5 log 5 x power 5 times x square plus 1 plus 3 by 5 1 by root 5 tan inverse x by 1 by 1 root 5. So this will gives you after simplification as what? 1 by 5 log 5x square plus 1 plus 3 by root 5 tan inverse of root 5x. This means this will be your capital Fx. Using the second fundamental theorem, you will get f of 1 minus f of 0. This will gives you 1 by 5 log 6 plus 3 by root 5 tan inverse root 5. Now 15th. So definite integral 0 to 1 x e x square dx will be what? First of all, finding the indefinite integration. This will gives you, we will be using x square equals to t as our substitution. This will gives you dt will be 2x dx. As you can see, the if x approaches to 0, t approaches to 0, x approaches to 1, t approaches to 1. Okay, so this means my definite integral can be reduced to half of integration 0 to 1 et dt. This means half of integration, the indefinite integration et dt is equals to half of et, which is capital F of t. This means using second fundamental theorem, you will get capital F of 1 minus f of 2, sorry, f of 0, you will get half of e minus half of e power 0. This means half of e minus 1 will be your final answer for this. Okay, now 16th problem says what? Definite integral from 1 to 2 5x square divided by x square plus 4x plus 3 will be what? Will be what? As you can see, first of all, we will be obtaining what? A 5x square, dividing 5x square by this term, x square plus 4x plus 3. We obtain what? Definite integral 1 to 2 5 minus 20x plus 15 divided by x square plus 4x plus 3 dx. You will get, separate them, definite integral 1 to 5 5 dx. Okay, minus 1 to 2 20x plus 15x square plus 4x plus 3. You know this integration directly, 5x 1 to 2 minus definite integral 1 to 2 20x plus 15x square plus 4x plus 3. Now name it I1. We will be now evaluating I1 will be evaluating by this. You will get what? Definite integral 1 to 2 20x plus 15 by x square plus 4x plus 3 dx. Consider I1 this. So this means 20x plus 15 is equals to a times derivative of the denominator expression plus b. Compare them, you will get a is equals to 10, b is equals to minus 25. This means you will have I1 is equals to 10 times of definite integral 1 to 2 2x plus 4x square plus 4x plus 3 dx minus 25. Okay, so definite integral 1 to 2 dx by x square plus 4x plus 3. This means if you substitute denominator is equals to t, what you can get is 2x plus 4 dx is equals to dt. This means your I1 will be 10 times of integration dt by t minus 25 integration dx by x plus 2 whole square minus 1 square. So this, you know, directly you will get I1 as 10 log t minus 25 multiply with half of log x plus 2 minus 1 x plus 2 plus 1. So after simplification, okay, you will arrive at this point, that 45 by 2 log 5 minus 45 by 2 log 4 minus 5 by 2 log 3 plus 5 by 2 log 2. So after using what? Your log property, you will get 45 2 log 5 by 4 minus 5 by 2 log 3 by 2. Substituting I1 in back, you will get your original answer, which is capital I will be 5 minus 45 by 2 log 5 by 4 minus 5 by 2 log 3 by 2. Okay, clear? So this will be your final answer. Okay, now the 17th problem, definite integral 0 to pi by 4 2 sec square x plus x cube plus 2 dx can be easily written as what? The indefinite integral will be what? 2 tan x plus x power 4 by 4 plus 2x will be your capital Fx. This means using second fundamental theorem, you will get f of pi by 4 minus f of 0. This means 2 tan pi by 4 plus 1 by 4 pi by 4 power 4 plus 2 pi by 4 minus 2 tan 0 plus 0 plus 0. This will gives you just what answer? 2 tan pi by 4 plus pi square pi power 4 by 4 power 5 plus pi by 2. This will give you 2 plus pi power 4 by divided by 1024. Okay, this will be answer for 17th problem. Clear? Now 18th. Okay, 18th problem says definite integral 0 to pi sine square x by 2 minus cos square x by 2 dx will be what? As you can say. So first of all, your capital I can be reduced to this form, minus 0 to pi cos x. How? Sine square x by 2 minus cos square x by 2. You all know what is it? It is just nothing but minus of cos 2x. So that's why it is written over here. So in now indefinite integral of what? Cos x dx is equals to sine x Okay, so sin x will be your what? Capital Fx. So this means capital Fx. Okay, capital Fx will be what? Sin x. Now by using second fundamental theorem you can get capital F of pi minus f of 0. This means sin pi minus sin 0. This means your integral definite integration value will be just 0. Now 19th problem says what? 19th problem says definite integral 0 to 2 6x plus 3 divided by x square plus 4 will be what? As you can see, so first of all the indefinite integral will be 3 times of integration 2x plus 1 by x square plus 4. This means 3 times of 2x by x square plus 4 dx equals plus 3 times of x 1 by x square plus 4 dx. So this will be just nothing but 3 times of, after substitution you will get 3 times of log x square plus 4 plus, and this is just direct value which is 3 times of 1 by a tan inverse x by a thing. So this will be your fx, capital Fx. This means now your value will be, definite integration value will be f of 2 minus f of 0. After applying f of 2 minus f of 0 and using log property, you will get 3 log 2 plus 3 pi by 8 as your final value. Okay, I hope it is clear. Now 20th problem says definite integral 0 to 1 x ex plus sine pi x by 4 will be what? As you can see, so first of all separate them. You will get indefinite integral as x ex dx minus. Okay, clear? So what we are using, as you can see, so first of all we separated it, this part x ex and this part. You know the direct integration for this will be minus cos pi x by 4 divided by pi by 4. Okay, this will be integration of this. Now we will be using here what? Integration by parts thing. So first function will be what? X, and second function will be what? Ex. As you can see, x integration ex dx minus derivative of first which is x and integration of second, you will get this. Now after integrating this you will get x ex minus pi by 4 by pi cos, okay, x by 4. So this means pi will be cancelled, you only left with this. So okay, so I hope that it is clear to you. Okay, now as you can see what you will have, so you can, so this pi won't be here, so 4 by pi. Okay, this must be 4 by pi. Okay, so this must be 4 by pi. Now what? Now by second fundamental theorem we obtain what? F of 1 minus f of 0. This means what you will get as your final answer. The final answer will be what? 1 plus 4 by pi minus 2 root 2 by pi. Okay, now the 21st problem says definite integral 1 to root 3 dx by 1 plus x square. Find it. So quite simple. So we know the indefinite integral for this is tan inverse x. This will be capital Fx. So this means capital, this value, this definite integration value will be capital F root 3 minus capital F of 1. This means tan inverse root 3 minus tan inverse 1. You know tan inverse 1 is just pi by 4 and tan inverse root 3 is pi by 3. This means pi by 12 will be your final answer for this 21 problem. Now the last problem for this exercise will be what? Definite integral 0 to 2 by 3 dx by 4 plus 3 okay, 4 plus 9x square. Okay, so very simple to do. So what you have to do, take what? So you can put you can rearrange your terms as 4 as 2 square and 9x square as 3x whole square. So putting 3x is equals to t, this means dx dx can be replaced by dt by 3. So this means 1 by 3 indefinite integration dt by 2 square plus t square. You know this indefinite integration directly. 1 by 3 multiply with half of tan inverse t by 2. Now substituting back t value in terms of x, you will get 1 by 6 tan inverse 3x by 2. This means this will be your capital Fx. If this is your capital Fx, this means what? You know that by second fundamental theorem your final answer will be capital Fx 2 by 3 minus f of 0. This will gives you 1 by tan inverse 3 by 2 multiply 2 by 3 minus 1 by 6 tan inverse 0. This is just nothing 1. This is 0. This term can be easily vanished. So 1 by 6 tan inverse 1 will be pi by 4. So 1 by 6 multiply pi by 4. This means pi by 24 will be your final answer. So this means answer or option C will be your correct option. Okay. So here our exercise based on this definite integration is now we have done. Okay, so I hope that you understood every explanation, every step. Okay, so this is it. Okay, so we will be back with a more theoretical part of this definite integration part, okay, topic, and also with some more examples and theory and exercise also. Okay, so thank you.